Any doubts with previous classes?
Good morning, ma'am.
No.
Good morning.
Good morning. Good morning, ma'am.
Morning, ma'am. Okay, we'll get into our session today. A very good morning to everybody. As children are coming in, we'll join them up. Yesterday's questions winners. I wanted answers for all the 3 questions together. It was Savina who gave the answer first, but it was for 2. Then there was one more person, but all 3 answers right was given first by Preeti. So congratulations to Preeti N. That's the first winner. Second one was by Jennifer, and the third correct answer was by Preeti S. So congratulations to Preeti N, Jennifer, and to Preeti S. I'm very happy that new children are joining in to give the correct answers regularly. So congratulations to all of them. And yesterday I gave you the marks for the test. I'm very happy to tell that around 14 children have got 25 out of 25. So I will just tell the names. Mugambika has got 25, Nancy, Ashwani Ratnam, Supriya, Kavishri, Dhanlakshmi, Devika, Usha, Jennifer J, Steffi P, Mehanas Fatima, Monisha Evangeline, Ashwani Ratnam. All these girls have got 25 out of 25. So you can clap for yourselves. I'm very happy that you are able to score this full marks. Congratulations. All the others also 1 or 2 marks except a few papers. Majority of our girls have done good. So congratulations. Those who didn't take up the test, let me know when you are ready and you have to take up the test so that we can enter the marks. So getting into today's class, I showed you diagrams for 3. One is how is electric field line for a charge or for a dipole which has equal and like charges. Then we saw equal and unlike charges. Then for a positive charge and for a negative charge. So today we will see how to draw electric lines of force when we have uniform electric field. Uniform in the sense at every point in that field, the electric field has to be the same. Then we call it as uniform electric field. Just observe, you will have one positive charge and the other side will be your negative charge. So if it is uniform field, we will only draw horizontal lines. So when you have these horizontal lines, it represents the field or the uniform field is observed. I want you to erase that up. You want me to call the name? I will call. One more line. Quick. Go to erase and erase up. So if you have these horizontal lines which are present, then we call it as uniform field. So this is a diagram for electric field lines. Now today's class, we are going to see what are the properties of electric lines of force, or we will see what are the properties of electric field lines. So what you're going to do here is, first property, electric field lines are imaginary lines. That's the first point. They do not exist. For our reference, we just keep them as imaginary lines. So first property, electric lines of force are imaginary lines. So you just put I and keep for the first point. What does the first point means? They have to be your imaginary lines. We will form a word now. So the first point continues with I. So when you see at I, you should understand they are imaginary lines. Second point, a unit positive charge placed in an electric field will tend. Tend means it will always move from, or it will move along the path where the electric field is acting. So what you have to remember is unit positive charge placed in the electric field will follow a path along the field line. Charge will move along the field line. So my second letter will be C. First line, First point is they are imaginary lines. Second point, the charge will move along your field line. Keep that in mind. The charge direction will be along the field direction. So first letter is I, second letter for charge, that will be denoted with the symbol C. We'll go to the third property. You can see here 1 coulomb charge is moving towards the negative, and electric field line is also in the same direction. That's our second point. Charge follows a path according to the field line. That's my second point. Third point, the electric lines of force emanate. Emanate means they start from a positive charge and terminate, or they end on a negative charge. Always it will start from positive and end to negative. So I'm going to use the word S. First point is I, which stands for imaginary lines. Second point is E. The charge line, electric charge line will be along the field. Third point, I'm writing it as S. It stands for, it starts from positive charge and ends on your negative charge. The fourth point, the tangent to an electric field at any point will give the direction of your electric field. So I'm going to mention the letter T. T stands for tangent here. Tangent to an electric field at any point will give the direction of your electric field at that point. So 4 points we have learned. First letter is I, E, S, T. I stands for imaginary lines. E stands for electric field will be in the direction of the positive charge. Third point, it will always start from positive and end on negative. Fourth point, tangent will give the direction of your electric field. You can see this. This will be the direction of your electric field. What is a tangent is? Any line which touches our circle at one point. We call it as a tangent. So here you can draw a tangent to the point where electric field is present, and that will give us our direction. Can you see the point P here? So from this point P, you can draw one line. That line will denote your electric field. P can be a point anywhere in the charge. And if you take one point and draw a straight line, that gives me the tangent. So fourth property of electric field lines is the tangent to an electric field line at any point will give the direction of your electric field at that point. Our next point will be these electric field lines can never cross each other, or in simpler terms, electric field lines do not intersect each other. So here, these electric field lines are not going to intersect each other. It means there are two values for the electric field. I show you a diagram. For fifth point, you're going to use the symbol I again. That is, they do not intersect each other or they do not cross each other. What happens is, you can see this diagram here. I've drawn a box here and you can see two lines. They are intersecting each other. This is not possible because the electric field E1 and E2 will be here. Again, you will have one center electric resultant electric field. So this is not possible. So what you have to remember is electric field lines will never cross each other. That is, at the point of intersection, we have to draw two tangents. But according to our fourth point, only one tangent can be drawn from a single point. This is basics of mathematics. If you have a point, one tangent only we'll be able to draw. So since if two lines cross each other, we have to get two tangents, which is not possible. So you have to keep in mind the fifth point. Two electric lines of force can never cross each other or they do not intersect each other. You should also remember electric field is a vector quantity. There can be only one resultant field at a given point, and that has to be represented by your line which is given for you. So 5 points. I'll tell you the alphabets. I, E, S, T, I. You can remember it. I, E, S, T, and I. I stands for they are imaginary lines. E stands for the electric lines field follows a path along the charge. S stands for electric field lines starts from positive and ends at negative. T, tangent in an electric field gives the direction of the electric field at that point. And the fifth point, two electric field lines will never intersect each other. Now, I want to ask you a question. Now, electric lines of force are crowded when the electric field is stronger, and the lines of force will be weaker, or they will be spread out when the electric field is weaker. So what this means is, now we are all talking about this corona